afternoon. So today I will give some numerical problems on multi-regulation of the transformer. So about this problem. The 6600 by 440 volts single phase transformer has an equivalent resistance of 0.02 per units and an equivalent reactance of 0.05 per units. Find full load voltage regulation at 0.8 power factor lagging if the primary voltage is 6600 volts. Find also secondary terminal voltage at full load. So these given values are E1 by E2, 6761 by 440 means E1 by E2. So that is E2 equal to 440 volts. We know that per unit voltage regulation, so the per unit voltage regulation is given by sigma r cos theta 2 plus sigma x sin theta 2 at lagging power factor. At a lagging power factor. So lagging. Lag 0.8 lagging. So if it is in leading, minus sigma r cos theta 2 plus minus sigma x sin theta 2, it is a leading power factor. So it is a lagging power factor means plus. Where sigma r is called per unit resistance, sigma x is called per unit reactance. Cos theta 2 is a power factor. So given value per unit resistance is this one is a per unit resistance. Per unit reactance is this one. Sigma value 0.02, cos theta 2 value power factor 0.8. So 0.02, 0.8, sigma x 0.05. If cos theta equal to 0.8, sin theta equal to 0.6. If we know the cos theta 2 value, then calculate sin theta 2, the value equal to 0.6. Therefore, voltage regulation equal to this is the voltage regulation value 0.046 per units. So voltage regulation value, that is value in per unit voltage regulation. Voltage regulation means we know that voltage regulation equal to this one. E2 minus V2 by E2 equal to this value. Here we calculate and equate circle. For primary voltage of 616 volts, secondary no load voltage is 440 volts. Given value. This one 440 volts. Therefore, E2 minus V2 equal to this value into E2. This value into this value. That is E2 value 440. This value 440. This is equal to E2 minus E2 equal to 20.25. From this, E2 equal to E2 minus this change. E2 value 440 minus this change 415.27. So secondary terminal voltage, this value is the secondary terminal voltage. So voltage regulation value we calculate 0.046 is the voltage regulation value. This is secondary terminal. Okay. Next. So here is the second problem. A short circuit test when performed on high voltage side of 10 kVA, this is the power rating of the transformer. 10 kVA is the power rating. So these are the voltage ratings of the transformer. 2400 volts. Single phase transformer gives the following data. So short circuit test data performed on high voltage side of the transformer. So voltage rating 60 volts, current rating 4 amperes, power rating 100 watts. If the LV side is delivering full load current, it is a rated value current at 0.8 power factor lagging and at 400 volts, find the voltage applied to HV side. what is the secondary side voltage? We need to calculate the secondary side voltage. So first of all, for calculating the voltage equation, we must calculate the resistance, reactance, and impedance for this part. Okay. So our short circuit test is conducted on HV side. So that means equivalent circuit parameters are we obtained on HV side. So equivalent resistance value, this value we know that. Suppose in short circuit test we have ISC value, short circuit current or rated current, power, PSC value, and PSC value. So we have three readings in short circuit test: current, voltage, power. So PSC, it is in short circuit test we get copper losses. That is PSC equal to copper losses means I square R. I square R. ఇక్కడ capital letters వాడడం, small letters వాడచ్చు, capital letters వాడడం. So I square R means ISC square R equivalent. ఏ సైడ్ చేస్తున్నాం టెస్ట్ హెచ్వి సైడ్ చేస్తాం కాబట్టి హెచ్ R equivalent of H. This is the PSC formula. It may here we use capital letters, it may be also small letters. In some cases R is nothing but small or H. Just equivalent resistance refer to HV side. Equivalent resistance refer to HV side. So from this we calculate the R value, R equivalent value. R equivalent equal to PSC by IC square series. So this R equivalent value equal to refer to HV side equal to PSC by ISC square. Power value 100 watts, current value 4 amperes. So this is the resistance, equivalent resistance. So impedance equal to voltage by current, V equal to IZ. We know that V equal to IZ. DC circuits V equal to IZ. So I equal to V by Z. Z equal to V by I. So from this we calculate the impedance value. Impedance Z equal to V by I. So we know that resistance plus reactance equal to impedance equal to resistance plus J into reactance. Resistance plus J into reactance. So magnitude, if you consider magnitude, impedance square equal to resistance square plus reactance square. So from this, reactance equal to impedance square minus resistance square root of. So this is reactance value equal to impedance square minus resistance square root of. Here we substitute the resistance value and impedance value, then we get the reactance. So these parameters are referred to HV side because when short circuit test is conducted on HV side, so we get these parameters: equivalent resistance, equivalent reactance, and impedance. These three are referred to HV side. Okay. Then these if you want to transfer these parameters into LV side, first you find the which one is the LV side, which one is the HV side. Okay. How we find the 2000 by 400 volts. Here given value is 2000 by 400 volts. This problem 2000 by 400 volts. That means primary side high voltage, secondary side low voltage. So primary side high voltage, secondary side low voltage. So high voltage to low voltage. The primary values, primary resistance, primary reactance is transferred to secondary and into K square. So K square to multiply K value, K equal to V2 by V1. K equal to V2 by V1 or E2 by E1. So V2 value and the V2 value, V2 by V1, K equal V2 by V1. And V2 value 400 by 2000. V2 by V1 400 by 2000. So K equal to 400 by 2000. 400 by 2000. 400 by 2000 means 1 by 5. So multiplied with K square. So the resistance value is 6.25. So this is multiplied with 1 by 5. 1 by 5 square. So we get equivalent resistance referred to LVC. Similarly, reactance value multiplied with K square. Okay. Next, full load current, secondary current value. So power rating of the transformer equal to 10 kVA. So power rating of the transformer equal to 10 kVA. So this is the power rating. This power rating. 10 kVA. 10 into K. K means 10 power 3. So K into 10 power 3. So that means 10 into 10 power 3, 10,000, this value. By voltage, secondary voltage 400 volts. So this is current. Full load current on secondary side 25 amperes. Power rating 10 into 10 power 3, that means 10,000. 10 into 10 power 10,000 by voltage 400, 25 amperes. So E2 minus V2 equal to, we'll call it as a voltage regulation. Voltage regulation equal to E2 minus V2 by E2. Then the formula. Here I will explain this one. So voltage regulation equal to voltage regulation. We know that voltage regulation equal to basic formula E2 minus V2 by E2 into 100. So this is the basic formula of voltage regulation. So this is also, when we express this value, this is also equivalent to sigma r cos theta 2, same formula for voltage regulation. Sigma r cos theta 2 plus sigma x sin theta 2. Sigma x sin theta. Sigma r cos theta 2 plus sigma x sin theta 2. Or it can be written, can also be written as sigma r cos theta 2 plus sigma x sin theta 2. Also written as, this is equivalent to resistance drop. That means I2 or equivalent of 2 and per unit resistance by E2 into cos theta 2 plus I2 x equivalent of 2 by E2 into sin theta into sin value. So this is I2 x equivalent of 2 by E2 into sin theta 2. So ఇప్పుడు మన voltage, so ఈ రెండు ఈక్వేషన్లు ఈక్వేట్ చేస్తే these two equations are equated. If these two equations are equated, E2 cancel, this E2 value, this E2 value cancel అవుతుంది, and E2 minus V2 equal to only these components. అదే ఇక్కడ ఇస్తుంది, this value. So E2 minus V2 equal to I2 r equivalent of 2 cos theta 2 plus I2 x equivalent of 2 sin theta. So first we calculate the difference, E2 minus V2 value, that is 13.16. We know the current value. This is the current value 25 amperes. Resistance, equivalent resistance for LV side. Plus cos theta power factor value 0.8. Same current value 25 amperes. Reactance value, this value, and sin theta. So we calculate E2 minus V2, that is 13.1. So we know that V2 equal to 400 volts. Therefore we calculate the E2 value. E2 equal to this value, some small value plus V2, and 400 plus this value. Okay. So next, so take this as a final problem. Example 1.26. 10 kVA, 2500 by 10 kVA, 2500 by, so voltage ratings. So 2500 by 250 single phase transformer, give the following test results. Open circuit test values, short circuit test values. Calculate the efficiency at 1/4 half full and 1.25 full load at 0.8%. So for efficiency calculate the efficiency at 1/4 half full load and 1.25 of full load at 0.8%. Calculate the load kV output at which maximum efficiency occurs. Calculate load kV at which maximum efficiency occurs. Also value of maximum efficiency. ఇది అక్కర్లేదు, ఇది ఇంకా నేను చెప్పలేదు కదా, ఇది తర్వాత. సో ఫస్ట్ extra compute the voltage regulation and secondary terminal voltage and rated load power factor of 0.8 lagging, 0.8 lead. So you run first a point A and point C one values calculate. Efficiency calculate, next regulation calculate. Efficiency and regulation. Okay. So first for calculating the efficiency, so efficiency calculate current value at different loads. Efficiency calculate the efficiency at different loads. 1/4 half full 1.25 of full load at 0.8 perfect. So first open circuit test has been conducted on LV side because this test is equal to rated voltage. 250 volts అనేది LV side కాబట్టి ఓపెన్ సర్క్యూట్ టెస్ట్లో మనకి ఏ లాసెస్ వస్తాయి, కోర్ లాస్ వస్తాయి. షార్ట్ సర్క్యూట్ టెస్ట్లో ఏ లాస్ వస్తాయి, ఫుల్ లోడ్ కాపర్ లాస్ వస్తాయి. ఓకే, సో short circuit test has been performed on HV side. See, short circuit test performed on, you know that short circuit test is performed on HV side. The 60 volts అనేది fraction of voltage. 60 volt is the fraction of voltage because we apply small voltage during short circuit test. So rated voltage on HV side. Rated voltage on HV side and first here we calculate the full load current on HV side. Power rating of the transformer equal to 10 kV, 10 into 10 power 3. HV side voltage 2500. So current on full rated current on HV side equal to power by power rating of the transformer, kV rating of the transformer by voltage. HV side voltage 2500. So the current equal to 4 amperes. That means rated current equal to 4 amperes. But when we prediction into 3 amperes, and is rated current power. So 3 amperes is not a rated current, 4 amperes is the rated current. So for that purpose, we calculate the copper losses at 4 amperes of current. At 4 amperes of current. So that means, so for 3 amperes of current, copper loss is equal to 45 watts. So for 4 amperes of current, what is the copper losses? So copper losses increase proportional to square of the current. Copper losses increase proportional to square of the current. So how much proportion increase? Current value increases from 3 amperes to 4 amperes. So that means copper loss also increases. So that means 4/3 whole square into 45 actual copper loss. So that is 80 watts is the full load copper loss. So unit losses at full load current also it is the full load copper losses. So these are the core losses. This is the constant. Core loss is constant. So here we calculate copper losses at rated value. Rated at full load value. So at what power factor? 0.8 power factor. So first of all, where we calculate the efficiency? Calculate the efficiency at 1/4 load, half load, full load, 1.25 full load, same power factor, 0.8. So first calculate the efficiency at 1/4 load. 1/4 load is calculate. 1/4 load is calculate. Load changes, current changes. Current changes means copper losses changes. Core losses is fixed, but copper losses changes. proportional to current. Okay, so here first case one, calculate the efficiency at 1/4 load. 1/4 load at point power factor 1/4 load. 1/4 load this core loss is constant. Ohmic loss is ఎట్లా డిక్రీజ్ అవుతుంది 1/4 whole square. 1/4 whole square into PSC value. 1 by whole square into PSC value 80. That is equal to 5 watts only. So that means at 1/4 load, copper losses becomes 5 watts only. Copper losses becomes 5 watts only. And output equal to power rating ఎంత మనకి 1000. అంటే 1/4 load అంటే ఎంత full load means 10,000 watts. 1/4 load means 10,000 by 4. 1/4 load means 10,000 by 4. So 10,000 by 4 into power factor. This is the active power. Actually 10 kVA power. The apparent power. kVA apparent power. Apparent power means volt amperes. Voltage into current. If you multiply volt amperes into cos theta value, so actually we have three powers. P equal to VI cos theta. So this is active power. VI cos theta value. So this what this one is watts. Reactive power. VI sin theta. VI sin the units is var. VAR var. We call it var. VAR. Next apparent power S. SN equal to VI. So the units in volt amperes. Volt amperes. So we have three powers. Watts, var. So when the transformer rating is expressed in volt ampere, E power, apparent power. So the volt amperes, kilovolt amperes, or megavolt amperes. So in cases some kVA also, volt amperes or MVA, megavolt amperes, MVA. Okay, MVA. Okay, so that means the transformer rating is expressed in this manner: volt amperes, kilovolt amperes, or megavolt amperes. So but this power efficiency is defined for active power. Efficiency is defined active power output by active power input efficiency. Efficiency is calculated for active power. So we have power rating is we have volt amperes rating. If you multiply it with the cos theta, we get the active power. So in this case, same. So this output equal to this is the volt amperes power rating. So this is the power factor. So volt amperes rating into power factor. 1/4 means we calculate the efficiency at 1/4 load. We calculate the efficiency at 1/4 load. So we calculate the efficiency at 1/4 load in this way. So efficiency formula, different formulas ఉంటాయి efficiencyకి మనం ఇక్కడ ఎక్స్ప్లెయిన్ చేస్తాను. So for example, if you want to calculate the efficiency, equal to output by input. So this is active powers, active power output by active power input. Output even writes to output equal to input minus losses. Input minus total losses. TL means total loss by input. So input by input to 1 minus total losses by input. 1 minus total losses by 1 minus total losses by input value. See here. 1 minus total losses, core losses plus copper losses. Core losses, 50 watts, 50 is same, constant, does not change. Core loss does not change from core loss does not depend on load. So 5 watts is the copper losses. Copper loss at this load at 1/4 load by input value. Input equal to 2000. Input equal to input equal to output plus loss and less. Input equal to output plus loss. Output ఏమో 2000. Total loss ఏమో this one. అంటే ఇక్కడ మనకు వచ్చిన ఇన్పుట్ని మళ్ళీ దీన్ని ఇన్పుట్ని వన్ బై ఇన్పుట్ అవుతుంది కదా. ఇన్పుట్ బై ఇన్పుట్ 1 మైనస్ టోటల్ లాసెస్ బై ఇన్పుట్. ఇన్పుట్ మళ్ళీ ఏమైనా రాసి అవుట్పుట్ ప్లస్ లాసెస్. అవుట్పుట్ ప్లస్ లాసెస్ అండ్ లాసెస్. ఇక్కడ 2000 plus 50 plus 50. So this is the efficiency at 1/4. Now calculate the efficiency at full load and half load. So this is the efficiency at full load. So full load is 1 minus total losses in the 80 plus 50. The 80 is the full load copper losses, 50 is the core losses. Full load output value and the same into power factor, and 10,000 into power factor 0.8 to 8,000. So full load output value. Total losses. So efficiency at full load is 94.1. 94.4. This is the efficiency at full load. Next, efficiency at 1.25 load. 1/4 load means 1.25 overload. Transformer gets overloaded. The transformer gets overloaded, copper losses becomes more and more. How much more means? So this is core loss is constant. So copper loss ఎంత పెరుగుతుంది అంటే 1.25 times పెరుగుతుంది. 1.25 times. So 5/4 means this proportion 1 by 1/4 5/4 whole square into copper loss. Same 5/4 whole square. Similarly, this power is also changes. This power is also changes. So that is 5/4 into 10,000. Power factor 0.8. This core loss is constant. Copper loss is 5/4 into 80. So the value is 98.2. So 5/4 means 1.25 times. 1.25 times. So 1/4 are 5/4 same. 5/4 means 1.25 times. So efficiency 98.28. The efficiencies are calculated. Load power factor 0.8 to 0.8. Actually, efficiency అనేది లీడింగ్ గా లాగింగ్ గా డిపెండ్ అవ్వాలి. ఎందుకంటే లాసెస్ కానీ ఏమి వీటి మీద లాగింగ్ మీద డిపెండ్ అవ్వాలి కాబట్టి. సో 0.8 దగ్గర అంత ఎఫిషియన్సీ, లాగింగ్ దగ్గర అంత ఎఫిషియన్సీ వస్తుంది. 0.8 లీడింగ్ దగ్గర సేమ్ అంతే ఎఫిషియన్సీ వస్తుంది. బట్ ఎఫిషియన్సీ డిపెండ్స్ అపాన్ లోడ్. Efficiency depends upon load. Okay. Next, voltage regulation calculation. Voltage regulation calculate must calculate the voltage regulation. We must have calculate the equivalent resistance, equivalent impedance, equivalent reactance, per unit resistance, per unit reactance at 0.8 power factor lagging in sigma cos theta 2 plus sigma x sin theta. మనం వోల్టేజ్ రెగ్యులేషన్ అనేది క్యాలిక్యులేట్ చేస్తాం. నెక్స్ట్ ప్రోగ్రామ్ అవుతుంది మై ప్రాబ్లమ్స్. Any doubts? Okay, next problem only. The full load voltage drop in a single phase transformers are 2% and 4% due respectively to resistance and linear reactance. The full load ohmic losses is equal to iron losses. Calculate full load efficiency and full load at unity power factor. Load power factor at which voltage drop is maximum. Load power factor at which voltage drop is 0. Okay. Voltage drop is single transformer. 2% and 4% is resistance drop and leakage reactance. Okay. Per unit resistance drop and the formula. Per unit resistance drop. I2 are equivalent of 2 by E2 into 100%. Current reactance drop and I2 x equivalent of 2 by E2 into 100 4%. Okay. So 2%, 4% current distance drop and current reactance drop. So multiply both above numerator and denominator with I2. దీన్ని న్యూమరేటర్ డినామినేటర్ I2 స్క్వేర్ మల్టిప్లై చేశాను. ఇది వస్తుంది I2 are equivalent of 2 multiplied with I2. So I2 square are equivalent of I2 E2 I2 E2 equal this value. The full load on classes I2 square are equivalent of 2 equal to 0.02 into rate voltage into current. I2 E2 means rated volt amperes. Full load on class equal 0.02 into rated volt amperes. So that is equal to iron loss given condition. The full load on class is equal to iron losses. Full load on class equal to iron loss. So దాని నుంచి efficiency calculate చేస్తాం. ఇక్కడ unity power factor efficiency on full load and unity power factor. Unity power factor means power factor equal to 1. Unity means power factor equal to 1. So the power factor equal to 1. Efficiency equal to power. Efficiency equal to output power. So that is the rated output into 1. Output by input equal to output plus total loss. So rated voltage into 1. Copper losses I2 square are equivalent to iron losses. So iron losses and iron loss equal to load on class equal to 0.02 into rated volt amperes into 0.02 into rated volt amperes. Iron loss equal to iron loss. Okay. Iron loss is equal to 0.0 into rated volt amperes. Which condition. So this is volt amperes cancel with the efficiency was 96.1%. Next, maximum voltage drop means maximum voltage regulation. Maximum voltage regulation condition perfect and last class derivation cos theta 2 equal to R2 by Z2 for maximum voltage regulation. Voltage drop 0 అవుతుందంటే ఇది cos theta 2 equal to x equivalent of 2 by Z equivalent of. ఇక్కడేమో x వస్తుంది 0 voltage regulation maximum అయితే resistance వస్తుంది. ఇది difference. Okay. For maximum voltage regulation R2 by Z equivalent of. For zero voltage regulation x equivalent of 2 by Z equivalent of. So this manner we calculate the voltage regulation. Maximum voltage regulation R equivalent of 2 by Z equivalent of 2. Zero voltage regulation x equivalent of 2 by Z equivalent of. Okay. Any doubts?